when I did that, I was probably at SPR, consulting firm.
Oh, so you're fully remote.
I would fully remote.
So pre-COVID.
We were talking about that?
Yeah, we were talking about it.
Oh,
Nice. I mean, well, I'm just still.
In remote for-
Pre-COVID. But yeah.
I was gonna say probably 98%. Just like 8, just like,
Oh, my goodness.
Oh,
yeah.
Yeah,
Well,
okay, yeah.
put all infrastructure underneath one place, like wireless VPN and wireless network.
Oh, yeah, that makes sense.
There's like 5 people going to. I gotta go and make sure the lights are still on occasionally. But it usually yells at me before they even yell at me. I get a word saying can't reach.
Yeah, no, I work for.
Which one?
Probably never heard of it. VPN systems. No, I can't heard of VPN, but they're part of the S&P 500. Okay, 60,000.
Biggest small company. The Kansas City based?
Their headquarters.
All right, I guess it's time to get going. So it's been fun being here as always at Community Day. There's so many passionate leaders, engineers, practitioners that enjoy building on AWS. We can all talk and share stories, have a good time. So my name is William Collins. I work for a network startup called Alkira. We build network software on the cloud. We use a lot of AWS. And today I want to talk about cloud networking, specifically Transit Gateway and sort of the road, the evolution of networking to Transit Gateway. I really like thinking in terms of like problems and solutions. So, you know, a gigantic company like AWS isn't just going to start inventing stuff that, oh, maybe someone will use it, maybe some will not. You know, there's usually some demand in the market, and the really good things are the things that, you know, customers are, you know, pestering them for, like, hey, like, this is how we have to do something today. You know, we need a better way to do this, you know, please, you know, come out with something. So my clicker's not working. Hold on. There we go.
Can I ask a question?
Fire away.
Do you have any opinion about Aviatrix? Number 2, what's your thoughts about Lattice?
I'll start with Lattice because I've been, of course, prototyping it and doing a lot with it. I think it's great. So one question I get a ton of is Lattice going to replace Transit Gateway, or is Lattice going to replace this other thing? And no, it's not. It's going to work with these other things. So if you think of Transit Gateway is like stopping at like layer 3, and then you look at microservices on top of that and you think service mesh networking, you know, service to service interactions, you know, that's where Lattice lives. And, you know, Transit Gateway is just lower in the stack. And then, you know, Aviatrix, Alkira, there's Proximo, there's a lot of different products out there on the market. You know, this is a growing market, and, you know, all of them have their, you know, things they do really well. You know, rising tide raises all ships. And since they're a competitor of ours, that's, you know, we're all stopped there. So, so going into, networking and Empire, I'm going to look at networking and Empire, and there's a little story behind this. This is going to be really different than anything I've ever done before. So a few weeks ago, my 7-year-old, he's going to a Star Wars themed birthday party. So he is not old enough to really watch the Star Wars saga and understand it and, you know, go into all these things. So I'm giving him the bird's eye view. You know, these are the rebels. This is the Empire, you know, just kind of pretty basic explanation. And showing him pictures, small video snippets. We land on Darth Vader and it's tunnel vision. He's like, that's a mean man right there that's in that outfit. So we started talking about it. And then I thought, you know what? What if Darth Vader was an AWS customer? You know, they'd be a gigantic AWS customer, but they'd also be a hard one to work with, this empire. They have gigantic scale, but it would be a tough customer. I would feel bad for that AWS account exec, because if you get something wrong, you know, they got the Death Star, they're going to blow your planet up. It's going to be bad. So I'm going to look at this story in this talk track through the lens of like Darth Vader. And we're going to look at hybrid connectivity. So every cloud story, there's the first problem that you have to solve. And the way that I think about networking is kind of broken down into two different areas. So you've got to get to the cloud. If you're maybe a large enterprise and you have your own data centers, this is where your applications have lived for a really long time. That's where all your intellectual property is. Okay, how do we just get a connection to the cloud? Usually there's some sort of data center extension scenario in mind. We'll go into that a little bit. And then the next half is routing in the cloud. So you know, at the end of the day, TCP, IP, BGP, like a lot of the things underneath all this stuff, it's kind of all the same. But in the cloud, networking works different. Some limitations you have that, of course, you don't have on premises. And there's some benefits that make your job a lot easier. So we'll look at networking in the cloud. And then we will conclude with going into transit gateway. You know, what makes it special? And I've been doing the cloud stuff for a long time. Worked through some really hard designs, you know, square peg, round hole stuff. And transit gateway is honestly my favorite product, you know, released by a cloud provider up to this point. In between the sea of serverless this and serverless that. And it's just because it solved so many immediate problems that I was having and where I was in cloud at the time with a large company. It was just really timely. So again, going, you know, with this Star Wars theme, let's set the stage. You know, the empire is growing, you know, kind of like a large, massive global enterprise. And they've grown so fast, you know, they're trying to take over the whole galaxy. So this is gigantic scale. It's becoming very tedious to manage. And you have a lot of things that need to be connected. You've got star systems, you've got troop stations, data centers, you've got stuff everywhere. You have off-planet stuff. You're trading with, you know, different planets. And then you have like the peasants of Tatooine that you have to manage and all these different things. So all these things have to be interconnected. And whenever there's a crack in this armor and you start having connectivity issues, everything goes uphill to the CEO, the emperor. So goes to Darth Vader first, Darth Vader gets mad, and then you go up to the empire or the emperor, and then things get bad from there. And then decentralized data, you know, a lack of uniform security. This is a problem. One thing that is just historically relevant since cloud has been around. You have lots of accounts. Maybe you have some EC2 instance. It was created at a time when you didn't have, you know, your security stuff in place. There's some metadata on there. Somebody is able to get in from the outside and they start moving laterally. And, you know, next thing you know, they're in your data center. Bad news right there. So Darth Vader wants to lock all this down. He doesn't want any, you know, rebellion. He doesn't want those Death Star plans, you know, stolen. So first thing, hybrid connectivity. I've talked to a few folks at this event about the pains of using VPN tunnels. Site-to-site VPN it's challenging. So you look at this type of scenario and you basically have a full tunnel from your infrastructure directly to the VPC. Site-to-site VPN connection, you have an active and a standby tunnel. You have two public endpoints. If you've worked in networking and this was your first go at cloud, you already think you're an expert because you've been doing this forever. This is a simple VPN tunnel. So Darth Vader sees this And he's, he didn't get to be the evil Sith Lord he is by, not thinking of things like redundancy, resiliency. So he's thought about this a lot. He doesn't like the idea of a single point of failure there. So what does he do? He adds a little more hardware. You have more VPN tunnels now. Each active tunnel is only shooting through 1.25 gigs for throughput, not a lot. And he really likes the idea of using all the stuff, like all the tunnels at the same time. He wants to use all the resources that he has. So again, he sees this design, and while he's thinking about it, those wheels in his helmet are turning. Next thing he knows, growth starts happening like crazy. So if the Empire, it's huge. They're going to have more than one AWS account. They're going to have a ton of AWS accounts. So that means they're going to have a ton of AWS VPCs. So as this starts to grow, complexity starts to grow. And I've never heard of any network engineer in my life, and I've been doing this forever, that it was just like, I really like using VPN tunnels. Just bring on the VPN tunnels. Because not only is it tedious to deploy, but it's tedious to troubleshoot. When something goes wrong, the first area that gets blamed is usually the network. So yeah, rough job right there. So as this is expanding, more VPCs, more tunnels, again, the wheels in the helmet start turning, and Vader says, hey, we're going to just shorten the span of these VPN tunnels. We're going to go into a direct connect location. So we're going to throw some hardware in there. So instead of having a full tunnel from the on-premises infrastructure directly to the VPC, we're going to have maybe some circuits or some partner connection from our hardware, our facilities, to this direct connect location. And then our VPCs, VPC A, B, and N there, they're going to be connected to some type of gateway, maybe a direct connect gateway. And this traffic, let's say I have VPC A needs to talk to VPC B. And this type of design and practice for most big enterprises, that traffic's actually going to come out of AWS. It's going to hit a router or a firewall and a colo, and then it's going to come back into AWS to the adjacent VPC. Vader doesn't like this. It's inefficient. So if the destination for this traffic is inside the cloud, why are we coming out of the cloud and then going back in? Just doesn't seem efficient, does it? So why is it that happens? So there's a terminal, or there's something you have to consider in cloud. I'd say a limitation of sorts. So if you look at transitive routing, and this is basically to say that I can use VPC peering. So if I have VPC A and B, I can peer them directly, and traffic is passed, life is good. But say that I want to route to another VPC through that one. So I can't route VPC A to VPC N through VPC B. So what this means is if I'm using like VPC peering alone and I'm not using anything else, there's no forwarding information base in a VPC. There's no routing protocols that say, hey, I'm going to give you the ability to route your traffic, to create route policies, and to basically control and limit the blast radius or failure domains here. So it's just kind of a one-to-one thing. Well, most times, more often than not, you don't want to say you have a security tool or something, some IaaS specific stuff for compliance. You don't want to have to put that in every single VPC. You want to have like a redundant and resilient set of VPCs across region where that stuff lives. And then you have, stuff being enforced from there. So again, Vader doesn't like this. It's not efficient. So to keep traffic inside the cloud, I'd say the next iteration of this design. So first thing we had was, traffic coming all the way out, going all the way back on premises to your data center, and then routing back up. And then the tunnel, it was a full tunnel from data center to VPC directly. The next iteration is usually a colo or a direct connect location that you're using as an intermediary kind of in between. And somewhere along I don't remember exactly when this design hit. I personally prototyped it pretty early on, but this is what is called the transit VPC. And if you think about lift and shift, almost sometimes has become like a bad word. It's a naughty word these days. Oh, you don't want to lift and shift things exactly as they are in your data center into cloud. It's going to be expensive. It's not efficient. It's not set up in such a way, because it was built in the early 2000s or something, that it's going to be efficient and scale properly in the cloud. So this transit VPC design is kind of like I'd say the equivalent of lifting and shifting your network directly inside the cloud. So in this design, our VPCs, communication from like VPC A to B, it'll stay in the cloud because it's going to route through this transit VPC. And in this transit VPC, we're going to place 2 appliances. In this example, they're Cisco CSRs. So these Cisco CSRs are going to use BGP over IPsec to each VPC that we have. And there's going to be a lot of them. Again, it's usually active standby, 2 tunnels per VPC. We're only using, one of those tunnels at a time. And we're also going to do the same thing with on-premises. So we're going to use BGP over GRE, BGP over GRE usually for that communication. So tunnels on the left, tunnels on the right. So, look at this design and think, okay, I'm a big enterprise, or I'm the empire, and I have 100 accounts, or say just 20 accounts, multiple lines of business, and I have like 100 VPCs. Think about how this design looks. And beyond that, there's the same throughput limitation. So at the end of the day, at least when I was on premises, I didn't have, if I wanted 10 gig optics, or I wanted, when I'm routing something and I'm in control of the hardware, I can kind of size that and deploy it. In cloud, a lot of these appliance-based services did not have the ability to scale up, due to the nature of IPsec and a few other things. So this design, on the surface, we thought, hey, maybe this is good, but Vader didn't think it was good. The network has failed me for the last time.
It's all software-based. There's no hardware acceleration there. Something does not scale at all.
Nope.
You can't really take advantage of it.
Yeah, even from a cost perspective, I was in a conversation, this is years and years back, but they were approaching this from a cost saving measure, but I was like, well, you're paying Cisco for the licensing of these CSRs, you're paying AWS to run these CSRs, you're paying the traffic coming out of the spoke VPCs over the VPN, the egress traffic from the transit VPC, you're getting billed from a lot of different areas. And then you scale out. How is this a cost saving exercise? It's really not. So transit gateway. So transit gateway essentially is and it really operates like once you use it and once you deploy it in a real environment, it doesn't really act and behave like the traditional hub and spoke networks that we're used to in the past. So it's going to be usually a regionalized. So say I'm in US East and I have a lot of VPCs that I'm connecting, and then I have my sites, my, say data centers or, remote sites that I want to land there too. I can connect all these different things through something called an attachment. And using these attachments is pretty simple. And Vader liked this design so much, the ability of the transit VPC is insignificant next to the power of transit gateway. So we got a customer quote. So what makes transit gateway easy? So I went ahead for these next few slides. I personally like to automate as much as I can, usually with Terraform or CloudFormation. But you could do all these things through the UI as well. But the one thing I like for examples is with a snippet of Terraform code, I can show you like, okay, these are the only required values to create said resource. So that gives you an idea of the complexity. So to create a transit gateway by default, I'm essentially just putting in a description and a name, and I can create a transit gateway. That's how easy it is. Now this keeps all the defaults on, and we'll discuss that in a second, but what I'm going to get here is a transit gateway and a default route table. And from here, I want to connect these VPCs. So this happens through a VPC attachment. And again, it's really simple. So if you have in your mind what we were just looking at through this like death by tunnels scenario, and then you look at this, much easier. So I'm just going to have, 3 lines there. So I've got the VPC ID that I'm connecting. I've got the subnet IDs for the traffic to route through, and the transit gateway ID that I created. So this will attach the VPC to the transit gateway. Awesome. That was easy. And one thing to add, so using the defaults. So when I create a transit gateway and I attach a VPC with the defaults, it's going to automatically enable route table propagation and in the design to actually use that default route table that the transit gateway is created. So say that we scale and we want more VPCs, then you'd want to probably disable that and use additional segmentation, which we'll get into in a second, because you don't want everything routing to everything, by default. So in terms of scale, you can provision 5+ transit gateways. It's a soft limit per account that you have, and have up to 5,000 attachments. So it's as easy as it is to attach a VPC to the transit gateway. And it really fits well with, like most large companies have some sort of intake process. So something new comes along, new product, new service, you have a new VPC maybe, and this VPC has a life cycle. So that life cycle, there's going to be things that are built with the VPC and destroyed with the VPC eventually. And that VPC attachment fits right in there, really easy. So say for instance, and I'd say this is paramount for security, because one thing that I heard a lot of when I first started working in larger environments with cloud, like there was a lot of synergy and a lot of like enthusiasm that like all you need is identity and access management. Like IAM is the only security you need. It's the new perimeter. You don't have to worry about security anywhere else. You just use IAM and that's life. But what if your IAM is not, what if there's a hole there? What if there was something deployed and, something happens, somebody squeaks in and they're easy, they can just laterally move from VPC to VPC straight down to the data center. It'd be easy. It would be a walk in the park. So this is where additional segmentation comes into play. So to do this is pretty simple. You create a resource, just a route table essentially, specific to the transit gateway, and you can easily just, I'd say it's a one-to-one mapping basically per attachment. So we're creating an attachment from VPC to transit gateway, and for each one of those, we may create like an additional route table, or we might want to consolidate some stuff like non-prod, maybe dev, QA, test, or like in some sort of non-prod segment, and then we have a production segment. Like say that you have healthcare, like PHI data, protected data is only going to be in prod. Everything else uses synthetic data. We are categorizing data at the highest possible level. That's how you want to segment, and it works. From here, you may be wondering, like, okay, we've got the VPC attachment, we've got the route tables, things are connected. Well, how do you control what routes to what? And again, this is pretty easy. 2 lines. You have route table propagation resource, or you can go into the console and do it as well. Just basically referencing your VPC attachment and the route table that you want to send routes through. And again, this is really simple. In terms of, I'd say, I did some sort of comparison a while back. Go ahead.
I was just gonna ask a question about the number of routes you have in the route table is still not unlimited. Isn't it like 2,000 or 10,000 or something like that?
Yeah.
And that sounds like a lot unless you work for an enterprise. And then that's not a lot at all.
Well, you don't summarize your routes and make them all clean and everything. Of course. No, I understand. So like I've actually, I myself, when Direct Connect first came out, I didn't know, this was back when like the documentation was not, I mean, I didn't, as a network engineer, I'm like, okay, we're just advertising this many routes. Well, like we had actually done some sort of change in a physical data center and had a whole bunch of host routes that happened to get advertised over the Direct Connect. Well, the Direct Connect's down. What's going on? We had no idea. We looked in like 100 places besides thinking that it was a, that type of issue. So I totally understand that.
It's just a gotcha.
Yep, definitely. And that's with everything in cloud. Everything's, that's why a lot of times why you have more accounts, more VPCs, like there are hard limits and soft limits, and the route limit is a hard limit. So Vader's happy, uniform routing policies. There's no rebellion happening now. And in this, let's just say in this alternate universe, the empire continued to grow. The Death Star plans were never stolen, and everybody lived happily ever after. Woohoo! And that is it. That's all I got.
What's your thoughts about CloudWeb?
I'll say this. So like Transit Gateway, when it was released, it immediately relieved active problems in like production environments I was working in. Like it immediately had a use case and it was like hit the ground running. Cloud WAN has not been so much, but I understand the problem that it's aiming to solve. And yeah, you just have trade-offs with everything. Like, do you want your WAN connectivity happening through a single cloud provider? You just have to think about those trade-offs.
Well, and Cloud WAN is not just about external, it's also an alternative to Transit Gateway.
Yeah, inter-regional stuff.
And it's actually modeled that for something Azure did.
vWAN. Yeah. Yeah, it's interesting. One thing that I do know that I was trying to mimic or make work like Transit Gateway. So I do LinkedIn Learning instructor stuff too. And we were going to do a course on automating Cloud WAN versus automating Transit Gateway. And they just, yeah. Yeah. So segmentation and the way that you would approach segmentation is a little bit different as well. So that's a big thing to think about too. With Transit Gateway, it's pretty simple. The use case is hammered out and it's been around for 2018, I think it's been, or yeah, 2018 for private sector. So it's been around for some time.
It's been enhanced doing like the Transit Gateway